Hello everyone! In this short tutorial we'll explore an interactive application designed to teach chemistry students how to classify crystal structures using the principal component analysis and partially square discriminant analysis. We were inspired by Linus Pauling's 1929 study on binary compounds, and this tool modernizes the research using machine learning techniques and statistical techniques. The main goal is to help students understand feature selection, dimensionality reduction, and chemical clustering without needing to write a single line of code. Let's walk through the 4 parts of the activity step by step. In the first part, students interact with the PCA tab and explore chemical elements. For this part, we use a dataset of chemical elements, each characterized by up to 74 numerical properties or features. These properties include atomic characteristics such as atomic radius, electronegativity, some thermal and physical properties, electronic properties, and even more specialized data such as values from the density functional theory. By default, the visualization, two-dimensional PCA plot, initialized with just 2 features selected, period and group, providing a familiar structure that reflects the conventional periodic table. We suggest to start the activity with students selecting a familiar group like alkali metals, halogens, or even more specialized group like coinage metals or precious metals. Their goal is to cluster these elements away from the rest of the periodic table using as few features as possible. From there, they toggle features like atomic radius or electronegativity, and they can see how the visualization updates in the real time and the element's position shifts. Students see whether their selected group become more distinct and which properties contribute the most to the separation. They can see it in the table in the bottom of the plot. The table shows how each feature contributes to each principal component and guides students in optimizing their selection. Once students done with this part, they go to the second part, clustering, where A-B binary compounds are visualized on the same PCA plot. Each compound appears as a weighted point between its elements, with color representing the structure, crystal structure, cesium chloride, sodium chloride or zinc sulfide types. The goal here is to see if we can do unsupervised clustering with elemental properties features and separate compounds by structure type. Students experiment with manual feature selection to find a combination that will lead to the visual separation, just like a real chemical research investigation. Here, the students can also toggle the features manually by group or selected ones and see the contribution table that can help them to understand their findings. And then, once the student is done with this part, they go to the second part of the activity, PLS-DA. This part we switch to supervised machine learning techniques. Students now classify the same AB compounds by structure type, but with a new data set of compositional features, like differences, ratios, averages of different chemical, physical, or electronic properties. They manually select the features they think might help, and the app shows how well model separates the classes visually by providing the PLS-DA scatter plot, and numerically by providing top feature contributions and some K model metrics such as accuracy, F1 score, and also it provides the VIP scores to understand which feature contributed the most to the model overall, and they can evaluate their findings. Once they finish it with a manual feature selection, students can go to the last part of the application, to the automated feature selection and evaluation. Here we provide the option to do the forward feature selection and backward feature selection. For the forward feature selection, the students can run it just with the 2 random features selected by the app, or they can select 2 most contributed features by the VIP score, so the VIP score should be the highest, and put them here and run the forward feature selection with 2 certain features selected at first. Here we can see what feature was added during the forward feature selection and how the PLS-DA visualization looks with each feature selected. Then we can go to the backward feature selection. Here it will take a little bit of time in order to calculate the results, because it starts with all 133 features and deselect the features one by one randomly. Now we can see the final result with an accuracy showed for each step, and same with visualization showed for each step of the backward feature selection. Activity is designed for a flexible use in a classroom, small groups, or individually at home. Students record their findings in a report, compare results, and reflect on which feature best predicts structure. By the end, we've not only applied PCA and PLS-DA, but developed deeper chemical insights and confidence with working with real data. Now we will go to the steps on the installation of the application. I'm going to start with the installation of the application on your own computer. First, you need to download the zip file with an application itself. Then you go here, you copy the path to your folder, you open the terminal, you go to this folder. After, I suggest you to create and activate the environment that you're going to use. On our channel we already have the video about the Conda environment, installation of them and using them. So once the environment is created, we have to install all the required libraries to use our application. To do so, you have to download, you have to use the command pip install -r requirements .txt. This command will install all the required file libraries into your environment, and from here you're ready to go. You can just use shiny run app.py, and that's it. Your application is already Here you can see the application itself. It is running on your own computer, so everything works. Here you have the PCA part, element mapping, clustering, PLS-DA, and evaluation. Okay, and now we're gonna cover the deployment of the application into the web. So to do this, you have to first you have to create the GitHub account, and you have to fork the repository that you just opened. Just click here, fork. You create the fork with the same name, that's okay. So once, it will take just a few seconds, yep. So once the fork is created, so you have the copy of the main repository in your own account. Then you go to the Connect POSIT Cloud. Here you can just log in with your freshly created GitHub account. You authorize everything, that's okay. Once you answer the questions, so you can just go to publishing of your application. So you click here to publish, you click here install, yeah, you can allow access to all your repos you have. So here we select Shiny, because we used Shiny library for that. So here you will see the PCA PLS-DA activity that you just forked. So branch name main, application, primary file for application app.py. So, and you just click publish, and it will take some time, but not so long, to publish it. So, and here you go, you have your application published, same application we just saw, but this one you can open with a link that you can copy like from here, or you can copy it here. Copy the link and share it with your students. I do not suggest you to use one link for many students, because the program still needs some power for calculations and so I suggest you to use for 2 or 3 users at one time, not more. So that's it. I suggest to use the web application link just for 2 or 3 students at the same time because of the limitations of the free servers. So if you want to share it with more students, you can go here to the home, click to the publish and publish this application again into your account. So you will have one more link that you can share with your students. So you can do it up to 5 applications by one account in free versions of the POSIT Connect. So now you can share different links with different students. That's it. Thank you very much for watching this video. If you have any question, you can go here to the repository and create an issue and just write here, like make a new issue, and write here if you have any questions to me about the application. Thank you very much.